people may not know, this is not a light vehicle. It's what, 7-story tall?
7-story
How many
tall.
meters roughly? That's
Yeah, so it's 23 meters.
23 meters. So it's literally a 7-story building lifting
Lifting
off.
off, absolutely. Yes,
Right.
yes.
And what is the weight?
Weight is around 50 tons.
50 tons.
Yeah, yeah.
That is like what, 5 elephants or something?
Yeah, it's 25 elephants.
25 elephants.
Elephants.
Oof.
Yeah. So it's a massive, massive rocket, and then it lifts off. And just to give an idea, right, the thrust of the first stage, the moment it lifts off, is over 100 tons. So it's 100 tons, and then just to in energy terms, it's 3 gigawatts of energy. It can light up an entire city for a few seconds. That's the kind of energy getting unleashed at liftoff.
Yeah.
Right, and then it lifts off and crosses the tower. And then what we do is that we call it as a roll maneuver. The rocket rolls and aligns itself to the trajectory.
Okay.
That is a single point failure. If the rocket is not rolling, you need engines firing to make it roll for 4 degrees. It just rolled perfectly, and then the rocket is aligned to the trajectory.
Right.
And then you pitch. Then pitch, you have turned towards the trajectory where you want to go to the orbit. So this roll and pitch maneuvers are very important. In fact, there are like rocket failures which happened because the rocket turned in the opposite direction.
And then you are supposed to like destroy it, or
Yeah, so there's nothing. We have to destroy the vehicle, and
there is a destroy mechanism also built in.
It's built in, and it's all. That is the only thing manual which goes after the liftoff.
Okay.
There's nothing else you can control. It's fully autonomous vehicle. The only thing you can do is like you can destroy the vehicle.
So there is like giant bomb inside the rocket.
Yeah, so there's a RDX squad throughout the rocket, which will cut the rocket into 2 pieces.
Yeah.
So the pressure is released and it falls down.
Right.
And so that is a very important safety mechanism for the rocket.
Yeah.
Which ensure that it doesn't cause any damage.
Yeah.
And generally first launches, most of them are terminated. Almost everything is terminated.
It must be very heartbreaking, right, to see the rocket lift off and you have to press the button too. Like that's but I guess a lot of rocket pioneers have to go through this. But in your case, so it all went absolutely picture perfect.
Absolutely picture perfect. And the only thing we couldn't test is the flight termination system, which is a good outcome.
Okay, yeah.
Which is a great outcome.
You can pray that you never have to test it.
Never have to test it. Yeah. And that's what. In fact, that's a milestone for a first launch, that you test a flight termination system, because it gets activated in almost all the first launches. And so then we tested, we rolled and we pitched in the right direction. And then there are a couple of launches which failed in the past, internationally, because the rocket went in the wrong direction. Can you imagine like a rocket being built?
Yeah.
And the direction is because of the software issue. It's coded, or the hardware issue is one situation happened where the assembly of the main sensor happened in the night, and the technician assembled it in the opposite direction.
Oh God. Yeah.
And then the rocket sensed it in the opposite direction and turned in the opposite. They have to destroy.
But like this, that's the point. Like this, there are probably thousands of failure points.
Thousands of failure points, and in fact, the complexity of a small rocket is that you have to optimize in grams. Because you have to get a payload of few hundred kilograms.
Yeah.
You have to optimize in grams to be able to get that payload. When you have a bigger rocket, you have the luxury of actually adding more redundancies. You can put multiple electronic packages, multiple systems. If that doesn't work, switches to other. But you have absolutely everything has to work. There's no other go. So that way, I think all systems have to work. There's no go, and everything was working well.
So this is like let's just keep going slowly. So this is still, have you reached max Q yet, or like?
So it's just like turning, and this just happens after the launch pad crosses.
Okay.
Then another 10-15 more seconds, and it's max Q.
Okay.
That means like the peak aerodynamic pressure, because the rocket is racing.
That's about 20 kilometers.
Around 10 kilometers.
10 kilometers.
Yeah, so around 10 kilometers, and 10 kilometers.
And that day was also cloudy. Are clouds an issue, because the rocket disappeared very quickly in the clouds?
Yeah. So that was a cloudy day. And we expected it would be a very sunny day, but it was a lot of rain the day before the launch. And
when it was raining, the rocket was soaking in rain, or it was covered?
Yeah. No. We do something called rainproofing. The rocket is rainproof.
Okay.
I mean, even if it launches in a heavy rain, it doesn't matter.
I see. Okay.
Yeah. So we rainproof it because we expect that it can happen. In fact, typically launches happen on islands very close to the shore, so cyclonic places. And continuous rain generally.
Sure. Okay.
So, and luckily July is not a rainy season in the the launch site, but the day before it launched, when we trained, and then typically that also can be a cause of delay, scrubbing the launch. Just it's not convenient to launch. We just hold the launch. Luckily that everything cleared on the morning.
Okay.
And it was only drizzle, light drizzle, which is good for launch.
Yeah.
And there was no thunderstorms, nothing. Convenient environment, everything. The nature gave way for the launch.
Nice.
And then it, like you said, it has disappeared within the clouds.
Yeah.
And then it was a beautiful launch, I would say. Like within the clouds, you see that flame coming.
Right.
I saw the picture. We yet to release some of the pictures, but I saw some of the fantastic shots.
And you had a multiple onboard camera, right? Recording the whole thing?
Yeah. We had multiple. We had 7 cameras on board.
Nice.
7 cameras on board, internal, external, and 2 on the outside and several on the inside to check the separations and various things. And then we have so many cameras on the ground tracking. You can track up to almost 40-50 kilometers.
Oh, nice.
Just because of the clouds, we couldn't track a lot, but generally we can track a lot because of we zoom it and track the cameras.
Okay.
So that way I think it was tracked well. And it lifted off, then Max Q crossed, and then Mach 1 crossed. Mach 1 is like
speed of sound.
Speed of sound, crossed the speed of sound. And then the rocket raised ahead. And the next big milestone now is everything is stable.
Yeah.
So the next big milestone is stage 1 separation. So the stage 1 separated at around 50 kilometers.
Okay.
And the separations, typically a good portion of the launch failures happen because of separations. Because the first time you're testing in the actual real environment.
Yeah.
So the first stage separated well.
And first stage is in some ways the heaviest portion of the rocket. Like how much of the 7-story you're shedding when you let go of stage 1?
Almost half of it.
Half of it, okay.
Yes.
Got it. So rocket is now at this point much lighter. A lot of fuel is also burnt off, and
in fact, almost 70-80% of the fuel is burnt off. So first stage is 30 tons of fuel.
Yeah.
All burnt in 100 seconds. So it's like you can see the majority of the rocket that works is.
And maybe people will be curious, which fuel do you use? What's inside?
Yeah. So the first the booster stages of the rocket, we use something called solid fuel, where it's a mix of few chemicals, ammonium perchlorate, aluminum powder, other few things, and there's something called HTPB. It's a mix of all these 3 coming together. So basically, because there is no oxygen in space.
Yeah.
What we will do is we have to mix all the fuel and oxidizer in one thing, and then that ignites and it goes. So that means it works in vacuum. For example, when you go on an aircraft, you use the atmospheric oxygen because aircrafts only fly maximum 10-12 kilometers. Right? But here the rocket goes to beyond to space, deep space where there's vacuum. So the initial phase is these chemicals come together and then form the fuel, and then it ignites, and then it takes. And and then the stage 1 separation, that's where in fact I was very confident of stage 1 separation because I've personally seen that, and so the design is robust, everything is perfect, and so I was fairly confident that it will go well. The moment we reach there, it will separate well, and separated like clockwork, and it was seen on the camera. Fantastic.
And the stage 1, the entire tank will fall off in the ocean. And it sinks. It goes to the bottom of the ocean.
Yeah. So it hopefully, it depends on the orientation it falls. So if it falls in some orientation, it could float.
Okay.
Could float for a very long time, actually.
I see.
So we'll. I hope where it is. I don't know today. Probably, maybe it might have sunk. With the high probability, it might have sunk.
Okay.